Welcome to Learning Algebra with Miss Rodriguez. By the end of this video, you will understand classifying real numbers. So here you want to classify each real number by identifying all the subsets it belongs to. So a subset is a smaller group of a larger group. So our large group here is real numbers, so every number is a real number. And a subset is a smaller group, such as rational, integer, whole number, natural, and irrational. These are smaller groups of the larger group. If we want to classify, that means decide what smaller group something belongs to. So for 3, because it is not negative and it is not the number 0 and it is not a fraction, we can specifically call it a natural number. Now, if we look at our chart, a natural number is actually a smaller, very precise group of the larger group of whole numbers, integers, and rationals. So if we look at the definitions of these words, 3 can also be a whole number, it can also be considered an integer, and it can also be considered a rational. For the number -7, because now we are saying it's a negative number, we cannot call that a natural because natural is the counting numbers. It cannot be the whole number because the whole number just includes 0 and the natural numbers. Now, the negative means it's an integer, and because it's an integer, it's also a part of the bigger circle, rationals. For 3, square root of 16, I actually have to simplify this number first in order to decide what category this best fits into. So the square root of 16 is actually equal to the number 4. And now, because this is a counting number, I can use this when I'm counting objects, then I can call it a natural number. And because it's a natural number, then automatically it's a whole number, it's an integer, and it's a rational number. For number 4, the square root of 2, again, I need to simplify this number. So I'm going to use my calculator to find the square root of 2. And I end up with a decimal that is a pretty long decimal. So I'm just going to kind of round it. So it's 1.414 ... means it keeps on going. Now, because this is a number that doesn't stop, then I call it an irrational number. And notice irrational is kind of off to the side. It's its own separate category of real numbers. So because this is a irrational number, it is nothing else. For number 5, I also have a decimal. However, the number actually stops, 4.25, and there's nothing else after it. So because this decimal stops, this is a rational number, meaning it's its complete opposite of an irrational. And our last example, pi, although it is a symbol, that symbol is used to represent the decimal equivalent of 3.1415. And this decimal also keeps going forever. So I'm going to represent that by using 3 dots. And because this number keeps going on forever, then it falls into the category of irrational. Thank you for watching. If you found this helpful, don't forget to like, subscribe, and share with fellow educators or students.